Tonight. We're joined by Alexey Soshin, who is a solution architect at Depop. I'm sure many of you are aware of Depop in the tech community. And he's going to be discussing mixing Scala and Kotlin. If everyone could kindly put their microphones on mute, just so we have a nice clear talk. And then what we'll do, if everyone can put their questions in the chat bot, and then I can ask them with Alexey at the end. But without further ado, I'll pass you over to Alexey.
Thank you very much, James. My name is Alexey Soshin. I'm a solution architect at Depop. And today we are going to talk about mixing Scala and Kotlin. So our agenda for today is first I would quickly introduce Depop and what we stand for. And then I'll touch on the point why we would even want to mix Scala and Kotlin. And then there are 4 points I'd like to cover. So collections, nullability, functions, and Corotins. So those are the 4 different topics that I'd like to discuss today. Sounds good? So first, a little bit about us. Depop is a marketplace for fashion. We have about 25 million users globally, about 30 million items, and more than 100,000 items added every day. So we are quite big and have a big scale. And in terms of engineering, we are about 100 engineers at the moment, around 200 microservices, and most of our microservices are written in Scala. So we are quite large Scala shop. We also have a Python monolith that we are slowly breaking down, but I won't talk about that much today. So every time I mention this talk, first of all, people ask me, but why even try to do that? So that also happened today. And there are a few reasons I came up with this talk and has been working in that area of mixing Scala and Kotlin for about past 2 years across 3 different companies. First of all, Scala was there first. So Scala first appeared around 2004. It has 10 years ahead of Kotlin in terms of code base. And if we look at, so it's not really a representative graph because it looks at the pull request of libraries, but that's the best I could find to estimate. Still, we could safely say that there is much more Scala code in the wild at the moment than Kotlin code, at least on the backend, and that's because Scala was there first. And we simply, first of all, that's good code. We don't want to throw it away. There's no reason not to reuse it. So we would like to use it as much as possible. A lot of that code is in libraries. That will be my focus of my talk. And the whole point is how can we reuse that code? Now, there is a dinosaur in the room, of course, and it's Java. So I don't cover Java much in this talk because in scenarios where you need to mix Scala and Java or Kotlin and Java are actually well supported. And there is a good reason for that because authors of both languages knew that Java has a huge code base, it has a lot of libraries, and they wanted to make sure that you can make good use of them. So that was one of the selling points of Scala when it came that you don't need to reuse, don't need to write those libraries again, you simply can use what was written in Java. And if we ever wanted to throw everything mankind achieved in the last 60 years or so out of the window, we still could write our microservices in Go, right? But then the question is, if Scala is a fine language, why not keep writing everything in Scala then? And I can list a few reasons for that from my experience. So the first reason is that Scala engineers are hard to find. And there is a lot of competition on the market for them, both in the UK market and in the US market. And once you do manage to hire a Scala engineer, you want to put them on the most difficult tasks. But no, not all of the tasks in your company are difficult. And some of the tasks are pretty mundane, moving JSONs around, as we call it. And Kotlin is a good way to diversify your code base for those more simpler tasks. And there is a reason that Scala engineers are hard to find. It's because Scala is a hard language. I have another talk where I try to convince the audience that it's not that hard, but in general it is. I encountered it mainly at a company where I work that's called Wix, and it's quite a large Scala shop, about 300 Scala engineers, and we were hiring a lot of graduates out of the university. And those were top graduates from the top universities. Those were very smart kids. But still, for a lot of them, functional programming in Scala, and I put the red book, so probably most of you know what I mean, is hard. So it was for them very hard to adopt that. It took them literally months to get productive and write some code that could be put in production. And one of the reasons for that is that for the past 3 or 4 or 5 years in the university, they weren't taught functional programming. They had courses in C, Java, Python, but all those are mostly imperative procedural languages and not functional languages. So for them, adopting something like Kotlin is puts them in a much better place. And if you also in your company have juniors that struggle with the complexity, I would advocate for trying to adopt Kotlin for the onboarding. And so I listed two main reasons: scarcity of Scala engineers and maybe some difficulties in learning Scala for the junior engineers. But there is also a third category of engineers, and those are mobile engineers. And mobile engineers love Kotlin. Like for Android, it's basically the default language nowadays. And for them, it's a good place if you're adopting the backend for frontend approach, where you have an API layer that's in the backend but controlled by the mobile engineers. And this layer could be written in Kotlin, even though your company works in Scala, and then your mobile engineers can maintain that layer themselves. It's also working quite well from my experience for iOS engineers. So although they don't work in Kotlin, Swift is more similar to Kotlin than to Scala in some aspects. And hopefully, I convince you that there are some reasons that you may consider to mix those two languages. Now, my main point is that you shouldn't really put Scala and Kotlin code in the same microservice if you're doing microservices. So it's not about writing one class in Scala and one in Kotlin and then fighting with the compiler for the next 3 months. It's more about reusing your Scala code base. So back at Wix, we had 100,000 lines of infrastructural code in different enterprise libraries. And if your organization already has this Scala library, Scala code base that you would like to reuse, you still want to benefit from Kotlin, that talk is for you. Now,
I think could everyone just mute their microphones, please? I think someone's got music in the backgrounds. Apologies, Alexey.
That's totally fine.
Perfect, thank you.
Okay, so after we discussed some of the reason, now I suggest let's dive into the problems you may be facing. And I don't like the word challenges. Those will be problems for you. And let's start with something that seems relatively simple: compatibility between data structures. So if we look at those two functions, the top one is written in Kotlin, and the bottom one is written in Scala. Those are just signatures of them. We as people can argue that their input is exactly the same, right? So both of them are getting a map with key of type string and the value of a list of strings. So it's pretty obvious for us. But for the compiler, it's not obvious at all. If we try to invoke one function passing the argument from another, we would get this friendly message. So I promised you a lot of horrible compiler errors today. That's just the first one. I personally very much like the amount of exclamation marks. And that will be a common motive in this talk. Since we are on the JVM, it may seem that everything should just work. People were asking me why I was hired as a principal to solve those kind of issues. Like, shouldn't it just work? No, it doesn't work that easily. So that's what we want to do in our code. So as I said, for some reason, I listed a few of them. You have a Kotlin code base that now wants to reuse this Scala function for purposes that we and map string, a map that is a string and value is a list of strings, some monitoring values, as you may have noticed, and we want to invoke it from Kotlin. So we want first to use Java converters. So it's part of the Java Scala standard library, and it has a lot of adapters for those cases. And then we will need to have an adapter function for that. So notice that we use a Java util map and Java util string instead of Scala ones. And that's the real trick. The reason is Kotlin was designed with built-in support for Java data structures. So as long as we use Java data structures in Scala signatures, it will work seamlessly from Kotlin. So that invocation, Kotlin invocation will work now. But how it will work from Scala side? Here we have some work to do. So that's even with the Java converters, we can't simply convert a Java map to Scala map. If we invoke as Scala on that, that's what we get from the Java converters. It will do a shallow conversion. It won't do a deep conversion, meaning that the list inside the map will stay a Java list, and it still won't work because of our Scala signature. So what we need to do is we need to do another iteration. We iterate over the map again over its values and convert each of them to a Scala list 2. So those are already 2 conversions. And as you see, that's still not enough. And we'll need to invoke to map on the results to finally get the Scala map that we want for our signature. So something that's very trivial in the Scala world. So this signature is basically in a lot of places, and just a simple immutable Scala map. But it requires quite a lot of work for that to work in an interoperable manner. And that's just a first example of the challenges. And the other ones will be even more fun. Next one, Scala option and Kotlin nullability. So one of the great features Kotlin language has is support for nullability inside the language. So you can simply say that this type can be nullable or it cannot, and then it will give you compiler errors, which is great. And Scala adopted a bit different approach with options. So you have an option that may contain nothing or may contain some value of a particular type. So those types have very similar meanings, both indicate possible absence of value, but they need to integrate between them somehow, and it's not that easy. So let's look at that example. In the Kotlin world, this function receives either a string or null. And in the Scala world, very similar function receives an option of type string, which means it can be empty or it can contain a string. But a nullable string from Kotlin is clearly not an Scala option of a string to the compiler. So those types are clearly not compatible. And compiler will scream at us and tell us that the types mismatch. So here we can use a different approach. And for that, we'll use extension functions and inline functions from Kotlin. So although Kotlin is not as powerful a language as Scala, it has some very useful tricks. And one of them is extension functions. They actually also exist in Scala as far as I remember. And we can say that any type, so let's start with the bottom part, any type that is nullable now will have a method called as option. And since it's a nullable type, we can compare it to null. And if it's null, we will return something called none. Otherwise, we will wrap it in something. We'll see in a second what it is, and return it. Now, it means that whenever you are in Kotlin code, you now on a nullable type, you can invoke as option, and some magic will happen. So what this magic is? Inline function means that this function is actually only it will be erased at the compile time. So it won't be another jump for our compiler, for our code. And it will be inline, and that's why we call it inline. And here we wrap the none make it optional empty. And in Scala, you can just do option and round brackets. Here we need to invoke option apply on the type. And basically that in one line, once you have this code in place, that in one line will convert any nullable type in Kotlin to Scala type. So that's a really nice trick, saves a lot of time, and compared to the previous one, it doesn't have any overhead. So it's a really great trick to know. And a lot of Scala libraries use option, so it's quite widely used. Moving on, next topic is functions. I guess everybody here likes functional programming. Functions are great. So let's dive into that. Again, on the left, we have a higher order function definition from Kotlin. And on the right, we have the same definition in Scala. You need to look really hard to notice the differences. But does that mean that they are actually equal? Let's see. Let's try to pass Scala lambda to this Kotlin function. So before that, we were attempting to call Scala code from Kotlin. And now we're attempting to call Kotlin code from Scala. And the reason you would like to do that, so usually you would like to call from Kotlin to Scala. It's easier, but sometimes Scala has much more intricate types. So sometimes you would like to be in the Scala world, produce those types, and then reduce them to something simpler and put them into the Kotlin context. So that's one of the reasons you would need to do something like that. So let's try to pass this lambda. And we get this wonderful error. Not many exclamation marks, but still a lot of fun when it says unit is not a unit because one unit is in the Scala world and another in the Kotlin world. And yeah, in hindsight, that totally makes sense. In the end, those are two totally different classes, right? So we figured out that those two are definitely not the same. And we could even see that earlier if we just look at the classes behind them. So lambdas are translated to classes, and those are two different classes. So those are totally different. They shouldn't be compatible. Although the syntax looks very similar, right? And since we figured out that two lambdas represent two different classes, if we change the return type of the lambda, the problem should still be the same, right? So previously we didn't return anything from a lambda. Now we return some constant value, but we figured out those classes are different. So for the compiler perspective, as we've seen previously, it should be totally different too, right?
Sorry, Alexey, just button.
Yep.
We've got around 7 minutes left on the call. So I think what we'll do, if, sorry, everyone with questions, I'll ask questions to Alexey maybe on an interview after, if that's okay. I just don't want to talk, but thanks, mate.
Absolutely. I think we can finish in 5. So turns out those are interchangeable, and you can pass Scala lambda to Kotlin, and also you can pass Kotlin block to Scala, which is really great. You don't need to jump through loops. In fact, the only reason we got that error previously is that the return type of the lambda was different. So although lambda doesn't return anything, it means it returns a unit, and that's where we fail. But as long as the return type is interchangeable, it means that the entire lambda from the JVM perspective will be interchangeable. So that's really cool. You can use it in many places again. And my last topic is Kotlin Corotins. So for those that don't know, coroutines are similar to lightweight threads or fibers. And here we have a Kotlin class with two methods. One is asynchronous methods that returns a deferred result. And another one is a suspending method, which is like blocking code, but instead of blocking a thread, it suspends the coroutine. And for Scala developers, coroutine context is like execution context in Scala, so you should be familiar with that. And now we would like to reuse that code again from Scala. So at first, until you try to run it, it will compile just fine. But when you try to run it, you will get something like that, which certainly looks not very pretty. Await method in Kotlin doesn't have any arguments, but compiler demands that we pass something called a continuation, and you have no idea what it is. The entire message doesn't make much sense. But let's then try to invoke the second method. So we have the async method and we have the suspension method. Maybe the suspension method will work better.
Yeah. And sorry, Alexey, there's 3 minutes left. So everyone, just a heads up.
Yeah, and although we have one argument, we require to pass a continuation as a second parameter again. No luck. Java to the rescue. What we can do is convert coroutine call, deferred value, to a Java future. And now Scala knows what a Java future is. It doesn't know anything about coroutines, but it knows about Scala futures. And that's great because we can use Scala future converters to read that future back and not lose in any of the concurrency. So that's a more complicated example. But again, for the concurrent code like servers, it's really useful. And we reached the summary. So I covered briefly the reasons to adopt Kotlin in a Scala company. It's relatively easier to adopt. Mobile developers love it. And there are reasons to keep using Scala. And you've seen some tricks how to mix them both. Last slide. We're hiring, so check our careers. And if you would like to follow me, here are some links. Thank you very much.
Perfect. Thanks, Alexey. That's really interesting. Everyone, as the video is 45 minutes long, I'll send over obviously Alexey's email, and we'll probably do an interview with him after, and I'll ask the Q&As, and we can run through that. But I hope everyone enjoyed that. Thanks, Alexey. That was really, really interesting. Everyone,
thank you very much.
And I'll speak to everyone soon. Thanks, Alexey. Take care. Bye.